Now that we finished the graphical approach for absolute value, before I get to the next problem, I need to define the algebraic manipulation. So we need to always do graphical and algebraic. Algebraically, absolute value of x is either a positive x if the inside is bigger than 0, the inside meaning this x, and that x if x is less than 0, but if it's less than 0, I slap a negative in front of it. That's the deal. So either when I see an absolute value, I drop the absolute value and it's as if it had no effect, or if I see a negative inside of the absolute value, I drop it and slap a minus in front of it. For example, if I see the previous graph, if I see number 46, the absolute value of x plus 2, if I wanted to get rid of that, I would say, well, that's either x plus 2 or that's a negative x plus 2, one of the two. Well, here, if this inside, if whatever this is bigger than or equal to 0, I don't need the absolute value. I'm done. And if this inside of the absolute value is less than 0, negative, I will have to slap a negative right there. And this would really say, you're looking at the line x plus 2 if x is bigger than negative 2 or equal, and you're getting negative x minus 2 if x is less than negative 2. And if you look at the graph up there, that's really showing in red, and this is really showing in green. Piecewise functions, if you remember those. Now let's look at that problem and move on. Now when I look at number 48, I really have to worry about splitting those, and there are two of them. I noticed that there's this t, so where does that change sign? It changes sign at 0, assuming this is the t-axis, and I have this t plus 1. Where does that change values at t equal negative 1? Anytime I have multiple conditions, an number line will do the trick. Now, I would know that I need to pick a point in there, a point in there, and a point in there. Sorry guys, I get a lot of interruptions working from home. Not that simple. I forgot where I was at. So if I pick a value in that region, let's say I pick t equal negative 2. I notice that this value is negative, and negative 2 plus 1 is negative. So this, if t happened to be less than or equal to negative 1, then that first t and that t plus 1 will require a negative in front of each of them because the values are negative in both cases. And what this will be, negative t minus t, that's negative 2t minus 1 if t is less than or equal to negative 1. Now, if I pick a value in there, let's say negative 1/2. Remember, I'm not after the answer. I just want to know if it's positive or negative. Negative 1/2 in there, that will be negative. So when I put a t, it picks a negative. However, a negative 1/2 in there plus 1, that's positive. So when I put this on, that really doesn't change. It doesn't need the absolute value. Just ignore it. This is if t is between negative 1 and 0. So if t is between negative 1 and 0, this would be negative t plus t is 0 plus 1, that's a 1. And the last, of course, if I pick t to be bigger than 1, let's say 0, say 1, that's positive, that's positive. That means I really don't need the absolute value at all. So that would be, let's see, t plus 1, and that actually bigger than, it could, that's a mistake, 0, not 1. No wonder I couldn't figure it out. So if I put a 0 in there, bigger than or equal this if it's not included. Alright, now if it's bigger than 1, that's 2t plus 1. And that's really how it is. If you want to graph it, the graph, I'm not that worried about the graph. If you want to graph this, when you plug in negative 1, you will get a 1, negative 1, 1. And with a slope of 2 down, 1 to the right. Since this is less than, you're going to really run this line, but you're going to run it to the left, that piece of the line, and that's included. And y equal 1 between negative 1 and 0, well, that's right there. And y equal 2t plus 1 if t is bigger than or equal to 0. If you put 0 and you get a 1, it picks up where this left off. And slope of 2 up, 1 to the right, there's the graph. Again, not a big fan of the graph. Not really, I'm not after the graph. I'm more of you understanding how the absolute value works. Another topic that comes up is a circle. You guys, x squared plus y squared equals, let's say, a 4. So this is a circle. Again, you've seen a circle before. We just want to elaborate on a few things that you might have maybe you know it, maybe not. If I decided to solve this equation for y, I could say y squared equals 4 minus x squared. That's still the graph. And when I square root both sides, I'll get y to equal plus or minus the square root of 4 minus x squared. So let's make sure we're solid clear on that. If I say I want y to equal positive the radical, that means y is always positive. Well, where's y positive? That's corresponding to this piece of the graph. So it's half a circle. Y equal positive the square root of 4 minus x squared is upper half of that circle. And y equal negative the square root. That means y is always negative. That's corresponding to the bottom half of this graph. So y equal positive is the upper half, and y equal negative is the bottom half of that circle. Also, I could have said, you know what? Let me solve for x. X equal 4 minus y squared. That's still the same graph. And x equal plus or minus the square root of 4 minus y squared. And if I go ahead and sketch another graph, just to demonstrate how this works, something again that you need to know for this class. And if I go by a circle, there it is. Well, if I decide to look at this in x equal positive the square root, x is positive to the right, you will get the right half of the circle. And if you decided to get the negative, that's x is always negative, you will get the left side of that circle. And if I refer to this, that will be this right half. And again, these are all the things plus more that are going to come up for us, and something that you need to know as we proceed throughout the course. So this is not automatic right now. Right now they review it a bit, but it keeps on coming back and forth as we do more and more of these sections. And the next problem, it says find an expression, something you're going to do a lot for the function whose graph is the given curve. They want the top half of this circle. Well, let's talk about this. The center is at 0, 2, with a radius of 2 up, 2 down, 2 to the right, and 2 to the left. So the circle is centered at 0, 1. What they want an equation for the top half, for this half. So if it's the top half, it's y equal. If it's the right or left, it's x equal. Move this over, and there it is. And if you square root both sides, y minus 2 will equal 4 plus or minus the square root of 4 minus x squared, and y would equal 2 plus or minus the square root of 4 minus x squared. And based on what we did, if I want the upper half, if I take this part, that will be the upper half, so I eliminate the negative. If this problem was to say find an equation for the bottom half, I would have took the negative. Another property comes up, find a function find a formula for the described function below. Now if I look at number 58, oh, you know what, with all the fun, oh my god, I am so sorry, I forgot to give you the page. In our book, this is on page 21. So this problem is in the Stewart book, our book, it's on page 521. And a rectangle has an area of 16 meters squared. Express the perimeter. Tell me what the perimeter is. Well, the perimeter of a rectangle is twice the length plus twice the width. Assuming this is the length, that's the width, or vice versa. It doesn't matter. They say express the perimeter as a function of the length. So they have no problem with this perimeter equal. Twice L is okay. They have a problem with the width. They want it only in terms of L. I need to get rid of this width. That's where this second piece of information comes in. I know the area of a triangle is, rectangle is length times width, Since I want to get rid of W, I'll solve for W. So this is like systems of equations, and I'll substitute the value of W right there. And I would say the perimeter will be twice L plus 32O. You know what I meant, right? The L. 32 over L. Or you could say over L squared to L. You don't have to. That will do it. Either of those will do. And if we look at the last portion, there's a problem I skipped. Number 60, I'd like to do if I have time. If I have time at the end, I'm going to do it. Remember, I have 15 minutes. Otherwise, they won't let me upload this in YouTube. And even odd is a big deal on the long run. Remember, if I throw a negative in for x and it disappears, that's an even function. And if I throw a negative in for x, it ends up multiplying the y by a negative, that's an odd function. I'm going to do this. You should do it both graphically, not with a graphing calculator, and algebraically. Algebraically, you replace x by a negative x, and you simplify. You're trying to see if the x disappears. If the x disappears, this is an even function, meaning, is this what I started with? Well, it is. Then we say this is an even function, and that's a big deal because even functions are symmetric with respect to the y-axis. If you looked at the graph, this is a rational. Rational function. We have no vertical asymptotes. Horizontal asymptote is y equals 0. If x equals 0, y equals 0. So I'm thinking a graph starts next to an asymptote and ends next to an asymptote. I noticed that the top is always positive and the bottom is always, this graph is always positive. So my options would have been either this or something like this. Well, I know it can be that because x is always positive, or y. And on the right, it could have ended up being like this or like this. Well, it can be this. So the graph is up there, and I know that's symmetric with respect to the y-axis, which makes it an even function. Anything I do in these videos, you have a question on, you're welcome to bring it to the class discussion. 76 is another one of those. I want to do the algebraic. Algebraic, you replace x by a negative. That's negative x. And I notice that's negative x times absolute value of x. This is not where I started with. This function is not even. I factor a minus out of it. Since this is what I started with, that's satisfied that this is an odd function, symmetric with respect to the origin. If I wanted to graph it, I will have to say f of x equal, if the inside of this is positive or 0, I don't need the absolute value. Which means what? This is x squared. And if the inside is negative, then this x will remain, but this will be replaced by a negative x. That will be negative x squared. So if I look at this graph, I'll notice that I want x squared if x is bigger than or equal to 0, 1, 1, 2, 4. So that's how it looks like. And negative x squared if x is less than negative 1, negative 1, negative 2, negative 4. And this graph is symmetric with respect to the origin. Alright? I'm not going to have time to do number 60. I'll be more than happy to do it in class. You try it as a homework. See what happens.